Experimental study and analysis of hydraulic characteristics of diaphragm gas flow meter. The extensive classification of gas flow meters based on the principle of operation includes diaphragm, rotary, turbine, differential, Coriolis, vortex, ultrasonic, and specified in more detail in the next slide. Diaphragm flow meters are used to measure gas consumption in a wide range from 1.6 to 160 cubic meters per hour, but in practice are used mainly flow meters with small flow rate 1.6 to 10 cubic meters per hour. Structurally, diaphragm flow meters consist of several assemblies. The diaphragm flow meter is a volumetric flow meter with periodic filling and emptying of variable volume chambers, in which the movement for this filling and emptying is mechanically transmitted to a counter and the flowing gas drives it. The operation of the diaphragm flow meter is connected at any time with filling one chamber, emptying the other chamber from the same compartment, and pausing for the other two chambers located in the adjustment compartment. The main characteristics of a diaphragm flow meters relate to their accuracy, the dependence of the error of the measured amount of gas on the flow rate, pressure, or temperature of the gas. From hydraulic point of view, however, the dependence of the pressure loss during different flow through the diaphragm flow meter is interesting. The characteristics delta P equals FQ. The hydraulic characteristic is also interesting due to the fact that the diaphragm flow meter is a volumetric type of flow meter. As described above, its working principle is based on discretion or portion work. When switching the sliding valves, which achieves the sequential filling and emptying of the chambers, moments of stopping and starting the respective flows should be expected. The interruption at the time of the switching can be expected to result in pressure and flow fluctuations. This problem is not commented in the commercial production characteristics of the different companies and in the study of diaphragm flow meters. In connection with the implementation of the planned study about the hydraulic characteristics of a diaphragm gas flow meter, a laboratory installation was built. The supply of the installation is with a reciprocating compressor 1. The tested diaphragm flow meter then is type BK G2.5T with nominal flow rate 2.5 cubic meters per hour. By the pressure reducing valve 7, the required working pressure in the system for the tested diaphragm flow meter then is adjusted. During the study, the two important hydrodynamic parameters were measured and calculated: the volumetric air flow rate Q and the pressure drop delta P with a differential pressure gauge 11. During the study, at a constant air flow through the flow meter, then the sequential filling and switching of the volumes caused pressure pulsations from minimum through current to maximum pressure values and vice versa. The frequency of the pulsations is directly related to the flow volume. The obtained results gave grounds for introduction of additional hydraulic characteristics of the diaphragm flow meter, the resistance characteristics estimating the pressure pulsations depending on the flow, which is introduced above. This characteristic is defined in Formula 1. Another characteristic which determines what part of the pressure pulsations make up a measured average pressure drop is defined in Formula 2. You can see the results of studied diaphragm flow meter type at two different inlet pressures. The both graphs show three characteristics: the dependencies of the maximum, average, and minimum pressure drops in the flow meter during different flow. The actual characteristic delta P is the mean curve and expresses the mean pressure drop delta Pm in the flow meter at the respective flow rate Q. The other two graphical dependencies show the upper and lower ranges in the change of the pressure drop as a function of flow. Regardless of the complexity of the studies, characteristics delta P maximum and delta P minimum equals F are symmetrically located with respect to the mean resistance characteristic and have a clearly defined quadratic dependence. The correlation curves are very close, which is confirmed by the combined graphs delta P for the two inlet pressures presented on the graph. This shows that the inlet pressure in the gas system is not affected by the performance of the flow meter and allows to write a generalized equation 3. Another important conclusion of the study concerns the pressure pulsations determined depending on the equation 1. The experimental results in the study are presented in figure 6 as a correlation between the change of the pressure pulsations and the increase of the flow volume of the gas. The dependence analysis shows the indisputable linear increase of the pressure pulsations with the increase of the flow rate. In addition, with an increase in the working pressure, there is a slight increase in these pulsations, as evidenced by the correlations describing the process. Pressure pulsations are a significant part of the total losses and should be reported. The equation 4 shows that despite the relatively high share of pulsations in the total pressure drop, in absolute values they are comparatively small. Given the volume of the gas located between the flow meter and the consumer, a reasonable assumption can be made. The impact of pressure pulsations is insignificant as this volume of gas acts as a cumulator and damper of these pulsations. Experimental results of the hydraulic characteristics for the pressure drops and flow rate of a common diaphragm flow meter have been obtained from our own studies. A correlation dependence describing this characteristic with a high value of correlation coefficient is derived, which has a quadratic character. At nominal flow, the pressure losses in this type of flow meter are 0.4 millibars. The pulsation character of the pressure change in the diaphragm flow meter has been established. This pulsation is evaluated by the introduced characteristic pressure pulsations. A linear proportionality of the pressure pulsations depending on the flow rate has been established. In relative and absolute form, the pressure pulsations are determined. The result of the research can be used in the design, analysis, and evaluation of the operation of gas systems. Thank you for your attention.